Space is vast and full of wonders, a realm of infinite possibilities and untapped potential. It also holds the key to Earth's future energy needs, offering a solution to one of humanity's greatest challenges. China, a leader in technological innovation, is taking on a bold challenge, pushing the boundaries of what is possible. They plan to build a space solar station, a monumental project that could revolutionize how we generate and consume energy. This station will harness the sun's energy, capturing the immense power of our closest star. It will then beam this energy back to Earth using advanced technology. This is a game changer, a leap forward in our quest for sustainable energy. It could provide clean and sustainable power for generations to come, ensuring a brighter future for all. Imagine a world powered by the sun, 24 hours a day, 7 days a week without interruption. No more reliance on fossil fuels, no more harmful emissions polluting our atmosphere, no more worries about polluting our planet, preserving its beauty and health for future generations. This is the promise of space-based solar power, a vision of a cleaner, greener world. China's ambitious project could make this a reality, turning science fiction into science fact. This is not science fiction, but a tangible future within our grasp. This is the future of energy, a future where the power of the sun is harnessed to sustain our world. Space solar stations sound like something out of Star Wars, a futuristic concept that seems more like science fiction than reality. But the technology behind them is firmly rooted in science. Here's how it works: a blend of advanced engineering and innovative thinking. First, capturing sunlight in space, a process that begins with the deployment of massive solar panels. Giant solar panels much larger than any on Earth are launched into space. These panels are designed to withstand the harsh conditions of space. These panels are positioned in geosynchronous orbit, meaning they rotate with the Earth and stay fixed above a specific point. This means they stay above the same point on Earth, ensuring a constant and reliable source of solar energy. In space, there's no atmosphere to block the sun's rays, allowing for uninterrupted exposure to sunlight. The panels receive constant, intense sunlight, far more than what is possible on Earth due to atmospheric interference. Next, converting sunlight to energy, a critical step in the process. The solar panels convert sunlight into electricity using advanced photovoltaic cells. This happens through the photovoltaic effect, where sunlight is directly converted into electrical energy. It's the same way solar panels on Earth work, just on a much larger scale and with greater efficiency due to the constant sunlight. Then beaming energy back to Earth, a fascinating and complex process. The electricity is then converted into microwaves or lasers, forms of energy that can be transmitted over long distances. These are highly focused beams of energy, designed to minimize dispersion and energy loss during transmission. They can travel long distances with minimal energy loss, thanks to their focused nature and the vacuum of space. These beams are directed to receiving stations on Earth, which are strategically located to capture the incoming energy. Finally, converting energy for use, the last but crucial step in the process. The receiving stations on Earth capture the energy beams, using advanced technology to ensure maximum efficiency. They convert the energy back into electricity, ready to be used by homes, businesses, and industries. This electricity is then fed into the power grid for distribution to homes and businesses, providing a clean and sustainable source of power for our daily needs. Imagine a world where electric vehicles never need to be plugged in. A world where the hassle of finding a charging station or waiting for your car to charge is a thing of the past. This is not just a dream, but a potential reality with advancements in wireless charging technology. Picture homes powered entirely by clean energy from space. Imagine a future where every household is self-sufficient, drawing energy from the vast expanse of space. Constant and reliable power supply. Space-based solar power has the potential to revolutionize how we power our lives. By harnessing the sun's energy from space, we can capture more energy than ever before. Of weather and daylight hours. For electric vehicles, space-based solar power could mean no more range anxiety. Imagine driving long distances without the constant worry of running out of power. This technology, seamless and uninterrupted driving experience. EVs could be charged wirelessly, even while driving. This means that as you drive, your car could continuously receive power, eliminating the need for frequent stops to recharge. This would eliminate range anxiety and make EVs a truly viable alternative to gasoline-powered cars. The convenience of wireless charging would make electric vehicles more appealing to a broader audience. Charging times: the high energy beams from space could charge EVs much faster than conventional charging stations. This means less time waiting and more time on the road, making electric vehicles more practical for everyday use. For homes, space-based solar power could provide clean and sustainable energy. Imagine a world where every home is powered by an endless supply of energy from space, reducing our dependence on traditional power from space would be available 24/7, regardless of weather conditions. This means that even on cloudy days or during the night, your home would still receive a steady supply of energy. This would greatly reduce our reliance on fossil fuels and lower carbon emissions. By switching to space-based solar power, we can significantly cut down on pollution and contribute to a cleaner, healthier planet. Energy independence. Become energy independent. By harnessing energy from space, nations can reduce their reliance on imported energy, leading to greater self-sufficiency and security. They would no longer be reliant on importing energy from other nations. This shift could lead to more stable energy prices and a stronger, more resilient. Space-based solar power is a game changer, but it faces significant challenges. Cost: launching and assembling massive structures in space is incredibly expensive. The initial investment for space-based solar power is astronomical. Technical complexity: building and operating a space solar station is a complex engineering feat. It requires advanced robotics, materials science, and energy transmission technologies. Maintenance and repair: maintaining and repairing a structure in space is difficult and costly. Space is a harsh environment and components will degrade over time. Space debris: the launch and operation of space solar stations could contribute to the growing problem of space debris. This debris poses a risk to other satellites and spacecraft. Section 5: Renewable Energy Showdown: Space versus Earth. Space-based solar power is not the only renewable energy source. How does it compare to other options like solar, wind, and hydropower? Sunlight in space is always available, unlike solar power on Earth, which is affected by weather and time of day. Space-based solar power can beam energy to any location on Earth, even remote areas. Earth-based renewables like solar and wind are currently much cheaper to deploy than space-based solar power. Solar and wind technologies are well established and continue to improve in efficiency and affordability. Section 6: China's leading role in space and energy. China is a rising power in space exploration and renewable energy. The country has made significant investments in both areas in recent years. China has an active space program with ambitious goals, including a permanent space station and missions to the Moon and Mars. China is the world's largest investor in renewable energy. The country is a leading manufacturer of solar panels, wind turbines, and electric vehicle batteries. China's space solar station project is a natural progression of its ambitions in both space and energy. The project has the potential to cement China's position as a global leader in technological innovation. Section 7: Global Impact. A new era of energy cooperation. Space-based solar power is a global endeavor. No single country can achieve it alone. International collaboration is essential for success. International partnerships can help to share the immense costs and technical expertise required for space-based solar power. Global cooperation is needed to ensure that the benefits of space-based solar power are shared equitably among all nations. Space-based solar power could become a source of international competition or even conflict. Clear agreements and regulations are needed to prevent this. Section 8: Ethical and environmental considerations. Space-based solar power raises important ethical and environmental questions. While space-based solar power is a clean energy source, the manufacturing and launch of spacecraft can have environmental impacts. The technology behind space-based solar power could potentially be used for military purposes. International treaties and agreements are needed to prevent the weaponization of space. The launch and operation of space solar stations must be done in a responsible manner to minimize the risk of space debris. Section 9: Conclusion: A bright future, powered by the sun. The quest for clean and sustainable energy is one of the greatest challenges facing humanity. Space-based solar power offers a bold and potentially revolutionary solution. While significant challenges remain, the potential benefits are too great to ignore. China's ambitious project to build a space solar station is a testament to human ingenuity and our desire to push the boundaries of what's possible. If successful, it could usher in a new era of clean energy abundance, transforming our world for the better. The stars are within our reach, and the future of energy may lie among them.